3H, mixing operations with integers. Alright, so essentially we're talking about order of operations again. Remember PEMDAS, or GEMMA, right? So PEMDAS or GEMMA were our two things, parentheses, exponents, multiplication, division, going left to right, addition, subtraction, going left to right, or grouping, exponents, multiplication, division, addition, subtraction, right? So order of operations with signed numbers works exactly the same as it did when we didn't have signs to the numbers. All we have to do with this is we now have to take into account the signs as we do each step. So let's try a few examples and see if we can make this work. So what if I have 2 minus -7 plus -5 minus 8. So 2 minus -7 plus -5 minus 8. Well, I've got I've got minus, addition, subtraction, so subtraction, addition, subtraction. Order of operations says that those happen at the same time, and we just go from left to right. So we have 2 minus -7. Remember with subtraction, we change it to addition. So we keep the first sign the same, 2. We change subtraction to addition. We change the sign of the second one from -7 to +7. 7 plus -5 minus 8. Right, so we turn it into addition. So 2 plus 7 is 9. So 9 plus -5 minus 8. Well, now we have addition. 9 plus -5. Signs are opposite, so we're going to subtract and keep the sign of the larger number. 9 minus 5 is 4. 9 is larger than 5, so we're going to keep it as a +4 minus 8. Now we have subtraction again. Remember to subtract, we turn it into addition by keeping the first sign, so 4, changing subtraction to addition, and changing the sign of this 8 to negative. When we're adding, if the signs are different, we're going to subtract and then keep the sign of the larger number. 8 minus 4 is 4. The larger number was 8, so we're going to keep its negative sign, and we come out with -4. Now, you may look at this and go, Mr. Davis, what are you thinking? Why did you change this to addition when we were just going to have to subtract again? And I understand that thought, because that can be a little confusing. Why would I do that? Why would I take a subtraction and turn it into addition so I can subtract again? The main reason is that it makes sure that we get the correct sign out of it, and that we don't make other mistakes along the way. So if we're always consistent that when we have subtraction, when dealing with signed numbers, that we change it to an addition problem, we can always follow the rules exactly as they are. Whereas if we only change it, if we have a negative sign somewhere, then we start having to make judgments of when to do it and when not to do it. And to be perfectly honest, it's best not to have to make those judgments. Follow a set procedure, use it over and over again. Practice makes, not perfect, practice makes permanent. And as long as we keep practicing the same methods over and over again, they're going to get ingrained into us that this is the way it's done. Let's try another one. We can get the PEMDAS and GEMMA out of the way. We don't need those up there anymore. So let's try this. What if we have open square bracket? And remember, a square bracket does the same thing as parentheses. -4 times -2, let's see, minus negative 7, close that square bracket, divided by 5. So that's a pretty moving there. So we have negative 4 times negative 2 minus negative 7 in the brackets divided by 5. So order of operations says grouping, right? We're going to do grouping first, which these square brackets are grouping all of this together. So inside those brackets, we're going to group. So if we're grouping, what happens here? Well, we're going to go through order of operations now. Well, we've got multiplication, we've got subtraction. Multiplication comes before subtraction, so we're going to do that first. Negative 4 times negative 2. Multiplication, if the signs are the same, the result's going to be positive. Signs are the same, so we got positive, so 4 times 2 is 8. Minus negative 7 divided by 5. Okay, great start. 8 minus negative 7. We're subtracting, so we're going to turn that to addition by keeping that 8 as a positive 8. We're going to change the subtraction to addition. We're going to change this negative 7 to a positive 7. 8 plus 7 is 15. Divided by 5. 15 divided by 5, the signs are the same, so the result's going to be positive. Gives us 3. So we're following the same rules. It's still just order of operations. Just every step of the way, we look at the signs and determine what the resulting sign is going to be. Let's try one more. What if we do 8 plus 4 over negative 5 plus 2 plus negative 4. So I've got this whole thing, I've got addition, I've got addition, I've got addition, I've got division. Remember grouping. Grouping says that the top of a division is going to be grouped together. The bottom of a division is going to be grouped together. So we have 8 plus 4. They're both positive, the result's going to be positive, so 8 plus 4 is 12. We have negative 5 plus 2. Signs are opposite, so we're going to subtract. 5 minus 2 is 3. The negative sign goes with the larger number, so negative 3. Plus negative 4. So now I've got division and addition. Division comes first. 12 divided by negative 3. Signs are opposite, so it's going to be negative. 12 divided by 3 is 4. Plus negative 4. Now we have addition. The signs are the same. In addition, if the signs are the same, you keep the sign and add the two numbers. So negative 4 plus 4 is 8. So we get negative 8. So as I said, order of operations, same as it's always been. Just now, we're going to keep track of those signs, and we need to remember what the process is to determine what the sign is going to be for addition, subtraction, multiplication, and division.